Hello, we are back for modeling linear relationships. This is a little bit of a review of when we did writing equations for in standard form that we did back in 6.3, I believe. Nope, 6.4. So anyway, this is something that we are going to be working with working with two different variables, coming up with an equation. This is really good practice, and it also will take a look at where the x and y intercepts are. And remember, an x-intercept is where it crosses the x-axis, and the y-intercept is where it crosses the y-axis. Okay? So it says fundraising. The Band Booster Club is selling t-shirts and blanket wraps to raise money for a trip. The band director has asked the club to raise at least $1,000. The Booster Club president wants to know how many t-shirts and how many blanket wraps the club needs to sell to meet their goal of $1,000. The t-shirts cost $10 each, and the blanket wraps cost $25 each. Write a linear equation that describes the problem and then graph the linear equation. How can the Booster Club president use the sales price of each item to meet the goal? So first of all, let's pull out what's important, what we know from this scenario. So we know the cost of the t-shirts, right? So it says that the t-shirts are $10 each. So they are $10 each. The blanket wraps are $25 each. And how much do they need to raise? $1,000. So now we have the information that we need to pull out of it. And if we use T for t-shirts, and if we use B for blanket wraps, then we can come up with this. So we know they're going to sell t-shirts, and they're going to sell blanket wraps, and they want to raise $1,000, right? We know that each t-shirt costs $10 each. And so for every t-shirt I buy, it's going to cost $10. And every blanket wrap costs $25. So every blanket they sell, they're going to make $25. Okay? So there's our equation. If we had used x and y, then this would be in standard form, which is the easiest one to do these with. Okay? All right, so we did all that up here, so I'm not going to rewrite that. Save you a little time. Now they want us to graph that function to find all the possible combinations of t-shirt and blanket wraps sold to reach $1,000. All right, so we have our linear equation of 10t plus 25b equals 1,000. So I'm going to rewrite that up here. So 10t plus 25b equals 1,000. And one way to do that is to find my x-intercept and my y-intercept, okay? Or in this case, my t-intercept and my b-intercept. So if t is 0, I need to find out what b would be. So 0 plus 25 is 25. Oops, I forgot my b. Equals 1,000. And when I take 1,000 and I divide it by the 25, that's going to tell us how much or how many blanket wraps that we can sell. So 40. Okay, so there's one. I can also find out how many for 0 blanket wraps. So if I take 10t plus 25 times 0 equals 1,000, this is going to be 0, so I'm going to have 10t equals 1,000, and we know that t is going to be 100. And if none of them is 40, and 100 of them is 0, 50 of them is going to be what? should be 20. Let's try it. So if I have 50t plus 25b equals 1,000, that's 500. And if I subtract 500 from both sides, I get 25b equals 500. And I'll bet you if we take 500 and divide it by 25, we get 20. And we sure do. So yes. All right, so we said that T stands for the t-shirts. So the number of t-shirts. And we said B was the blanket wraps. That's not easy to do. Let me turn a little bit. That's better. So the number of blanket wraps. And now I can graph these ordered pairs. So I have 0, 40. So if T is 0 and B is 40, there's a point. If T is 100, B is at 0. And if at 50, so there's 10, 20, wait, sorry, 50 would be here, and this would go up to 20 here. And then I can draw my line through those points. Let's get rid of the arrows. And that's how you graph them. Okay? So what does this mean? This means that the number of x-intercept, the x-intercept tells me how many t-shirts are sold if no blanket wraps are sold. Okay? So the number of t-shirts that need to be sold if no blanket wraps are sold. And the y-intercept is telling me how many blanket wraps are sold if no t-shirts are sold. Oops. Are sold. So the Booster Club can use the graph to find the possible combinations of t-shirts and blankets to reach $1,000. So he can use that graph, and that's going to help him figure out how much he would need to sell. So if he sold 25, he would need to sell 30. If he sold 25 t-shirts, he would need to sell 30 blanket wraps. And if he sold 75, then he would only sell 10 blanket wraps. Now, can he sell 150 t-shirts and it's going to equal 1,000 if all the t-shirts are $10? No, it's not going to work. And so it's not even on that line. So that's not a possibility. Okay? All right, let's take a look at the next one. It says a sandwich shop sells sandwiches for $5 each and bottles of water for $1 each. The owner of the shop needs to earn a total of $100 by the end of the day. Write a linear equation that describes the problem, then graph the linear equation. Make sure to label both x's with the appropriate titles, then use the graph to determine how many sandwiches the shop must sell if no waters are sold. And it looks like they're using W for water and they're using S for sandwich. So, what do we know about the sandwiches? Sandwiches, we know they sell for $5 each. And so, they are $5 each. Waters are $1 each. So the waters are being sold at $1 each. And how much are we trying to make? So the total by the end of the day needs to be $100. So remember, the total amount is always going to be your C. So it's going to equal 100. The number of sandwiches is dependent upon how much they cost. So it's $5 for each sandwich. So $5 for each sandwich. And they're going to sell some waters, and they are $1 a piece. And now I can use this to determine what goes, where the lines go. So this is going to be my number of sandwiches. And this is going to be my number of waters. Okay. All right. So remember what I said. The first couple of things you could do is to find out if your sandwiches are 0. What are your waters? How many waters can you sell? If you don't sell any sandwiches, how many waters can you sell? And then do the same thing for if you don't sell any waters, how many sandwiches you can do. And then halfway between there. Okay. So let's find out for 0 sandwiches. Plus W equals 100. So W would be 100 because 5 times 0 is 0. And so it's going to be 100. So it's going to be this one right here. If I sell 0 waters, so that'd be 5s equals 100, and divide both by 5, and divide both by 5, and we find that we can get 20 sandwiches. So 20 sandwiches. And I could pick any number through here. I am going to go ahead and pick 50 because it's right in the middle. Oh, wait, sorry, I'll go across here. 10's in the middle. So if I sell 10 sandwiches, that's 50. Subtract 50 from 100. So if I sell 10 sandwiches, I can sell 50 water bottles. Does it look like it makes sense? Yes, it does. You have 0, 10, 20, it's increasing. 150, 0, it's decreasing. This makes sense. So now what I can do is I can plot my points. 10, 50, and 20, 0. And then I can draw my line through those points. And there's my graph. Now, if I asked you if I sold 15 sandwiches, how many waters could they sell? Could you find it using this graph? And the answer is yes, we can. So 15 sandwiches, I know that it's going to be 25 waters. What if I say it's 5 sandwiches? Well, at 5 sandwiches, I can sell 75 waters. Okay? Okay, I think that's all we're going to do today. If you have any questions, please make sure that you see your teacher. Thank you.